Hello student, today we are going to start a new module which is the structural geology and stratigraphy. In that we are going to study folds and folding. So let us see what is meant by the fold. Fold is nothing but the undulations or bend or curvatures which are developed in the earth crust. Okay, the undulations which are created or developed in the rocks of the crust, then they are called as a fold. And this undulations is a result of stresses from to which these rocks have been subjected from time to time. Okay, so undulations are created due to the stresses to which these rocks have been subjected from time to time in the past history of the earth. Okay, due to the stresses, the undulations are created in the rocks of the crust, and these are called as an fold. Okay, so this fold uh, may develop in any type of the rock. Okay, in the previous lecture we have studied the different types of the rocks, means the igneous, sedimentary and metamorphic. This fold is developed in any type of this rock, and this fold is having a different shape. Okay, means this fold may be of any shape, and the geometry ranging from simple up arch bend to the downward curvature. Okay, the ultimate shape and the extent of the fold, it depends upon the number of the factors. The shape and the geometry of this fold is depends upon number of the factors like nature, magnitude, then direction, duration, for which these forces act upon this rock, and also the on the nature of the rock being affected. Okay, means fold is also depends upon the nature of the rock. Okay, and also the magnitude, direction, duration, for which these forces act upon the rock. Then this whole process of the development of the fold in the rock is called as an folding. Okay, means the undulations which are created in the rock, okay, is called as an fold, and the process of the development of this fold in the rock is called as an folding. Okay, this folding process is very slow geological process, and it indicates the efforts of the rock in the particular environment to adjust themselves to the changing force. Okay, means this folding is a geological process and it is very slow process. Folding is a brittle deformation where the rocks actually get broken and displaced when stress. Due to the stresses, the rocks are broken down, okay, into the small pieces, and they are displaced. Okay, this process of the development of this fold in the rock is called as a folding. Now we will see the different parts of the fold. Um First is the limbs, second is the hinge and the axial surface and the axial plane, third is an axis of the fold, then flange of the fold, crest and the trough. Now we will see each of this part in detail. So first is as an limbs. Okay, limbs means what? These are the sides of the flanks, or these are the sides of the fold. Okay, in the figure you can see these are the limbs. Okay, here these are the limbs, means the sides of the fold are called as an limbs. An individual fold will have a minimum of two limbs, at least two minimum limbs, um, an individual fold is made up of at least two limbs. But when the fold occurs in the group, they are very often do a middle limb will be common to the adjacent folds. Okay. So if the individual fold, if we consider, then it contains at least two limbs. But if the fold occurs in the group, a middle limb will be common to the two adjacent folds. Okay. So in the figure you can see that here is the limb. Okay, and it means here is the side of this fold. This is called as an limb. Okay, if we consider only such this part, then it contains the two limbs. Okay, but if this fold is occurs in the group, then what happened? The means it contains a middle limb which is common in both the folds. Okay, so here is the common limb here. Okay, then our next point is a hinge and the axial surface and axial plane. So first we will see hinge means what. In a folded layer, a point can be found where the curvature is maximum and one limb ends and the other limb start from that point. In the figure you can see this is a point where the curvature is maximum. Okay, the curve is over here is maximum, and here the one limb is end over here and another limb is start from this point. Okay, so this point is called as an hinge. Okay, so hinge is the point where the curvature is maximum and one limb is in over here and second limb or the other limb is start from that point. Okay, this is the point which is called as an hinge point. When the rock occurs in sequence and their all hinge points are joined together, they make a line. Okay, when the rocks occurs in the sequence, okay, and if we draw the if and their all hinge points are joined together, then they make a line. In the figure you can see here is the hinged line. Okay, this is called as a line. If the rocks occurs in the sequence and if the hinge points are joined, then it makes a line which is called as an hinged line. In this figure you can see this is an hinged line. When this hinge line is traced throughout the depth of the folded sequence, a surface is obtained which may be planar or non-planar, and this is called as an axial surface. Okay, in the figure you can see this is an axial surface. Here the hinge line is traced throughout the depth of this folded sequence, and the surface which is obtained which is called as an axial surface. This axial surface may be a planar sometimes or maybe a non-planar. Okay, so if it is a planar structure or the planar nature, then they are called as an planar. Then such a type of the fold is called as an planar fold. Means a fold is sometimes called as an planar fold if the axial surface is planar in nature. Okay, if this axial surface is planar, then it is called as an planar fold. Okay, and then if the axial surface is non-planar, then the fold is called as an non-planar fold. Okay, so depending upon the nature of this axial surface, the folds are of two types, non-planar and planar fold. Okay, also our next point is an axial plane. Okay, our next point is a So up to here we have seen what is meant by the hinge. Next is we have seen the hinge line means what. Okay, axial surface we have seen. Okay, and then we have studied the axial plane. Okay, next point is the axis of a fold. The next point is an axis of a fold. This axis of the fold is simply defined as a line which is parallel to the hinged line. Okay, if we draw in the figure, you can see here is an hinged line. Okay, and if we draw a line which is parallel to the this hinge line, then this is called as an axis of a fold. So here is the figure. In the figure you can see this is an axis of the fold. Okay, means if a line drawn parallel to this hinge line, then it is called as an axis of the fold. So this line means axis of the fold is showing here. In this figure you can see this is an axis of the fold. So this line representing the intersection of the axial plane of the fold with any of the bed of the fold. Okay, means axis of the fold indicating the intersection of this axial plane of the fold with the bed of the fold. Okay, so our next point is the plunge of a fold. Plunge of the fold means what? Uh, the axis of the fold may be a horizontal or vertical, or sometimes it is inclined. Okay, so the plunge of the fold is nothing but the angle of inclination of the fold axis with the horizontal as measured in the vertical plane is termed as a plunge of the fold. Okay, the angle of the inclination of the fold axis with the horizontal as measured in the vertical plane, then it is called as a plunge of the fold. And our last point is a crest and the trough. Crest means what? The highest point in the up arch fold is called as a crest. Okay, so here in the figure you can see this is an up arch fold. Okay, or we can say up arch fold is there here. Okay, and the line which is running to the highest point in an up arch force is called as a crest. Okay, and our next point is a trough. Trough means what? So here indicating the here is the trough. Okay, the line which is running to the highest point in the up arch fold is defined as a crest, and second term is a trough. A corresponding line which is running to the lower point in the downward fold is called as a trough. Okay, so highest point in the up arch fold is called as a crest, whereas the line which is running to the lowest point in the down arch force is called as a trough. Okay, this crest and a trough may or may not be coincide with the axis of the fold. Okay, so sometimes it is coincide with the axis of the fold, or sometimes it is not coincide with this axis of the fold. Okay, so up to here we have seen the different parts of this fold. Our next point is the classification of the fold. This fold shows a variety of forms. Means it quite simple, or depending upon the different uh, parameters, the folds are classified into different types. Okay, so two basic types of the fold are anticlines and synclines. So here anticlines is indicated by two arrows from the center point. Okay, anticlines indicating by the two arrows which are diverging from the center point, and syncline fold shown by the arrows which are coming towards the center point. Okay, which are pointing towards the center point in a hinged form. In the figure you can see this is an anticline fold, okay, and this is a syncline fold. So the anticline fold is defined as those fold in which the strata is of arch. Okay, means it becomes a convex upward. When the fold showing the convexity upward, then it is called as an anticline. Okay, and where the strata are down arched, means this become a convex downward, then the fold is called as an syncline. Okay, this syncline fold is exactly opposite to the anticline fold. In the figure you can see this is an anticline fold which is the convex upward. Here this is a syncline fold where the strata is is convex downward. Okay, so here in the anticline fold, the older rocks occupy the position in the interior of the fold. Okay, here one indicating the one type of the rocks, two indicating the second type. Okay, so here means older rock is occupy the position in the interior of the fold because it is an anticline fold. Okay, and the younger rock is younger uh, rock strata is on the exterior of the earth, exterior of the fold. Okay, it is in the anticline fold, whereas in the syncline fold the younger rocks occupy the position in the core of the fold. Okay, in the core of the fold the younger rocks are there, and in the uh, means what, the geologically younger rocks occupy the position in the core of the fold, and the older rocks from the outer flanks, provided the normal order of the superposition is not disturbed. Okay, in the figure you can see the here the older rock is in the older rock is in the interior side of the earth, then that type of the fold is called as an anticline. Okay, and when the younger rocks occupy the position in the interior or core of the earth, then it is called as an syncline fold. Okay, anticline folds shown by the arrows which are diverging from the center point, and the syncline folds are indicated by the arrows which are pointing towards this center point. Okay, uh, then depending upon means the different factors, the actual existence of the folds are simple and have been variously classified into the basis of different parameters. Okay, means fold showing the variety of forms. Okay, and depending upon the different parameters, the folds are classified into different types. So first we will see in your syllabus only the classification based on the position of axial plane is included. So we will study the classification of the fold based on the position of the axial plane. So it is means depending upon the position of the axial plane, the folds are classified as symmetric fold, asymmetric fold, overturn fold, isoclinal fold, recumbent fold, then conjugate fold, and last one is a box fold. Now we will see each of these fold in detail. So first fold is an symmetrical fold. Okay, first fold is an symmetrical fold. This symmetrical fold, in the figure you can see the both limbs are of equal length. Okay, the axial plane is essentially vertical. Here ax means the axial plane here is vertical. Okay, limbs are of equal length and they are deep equally on the opposite directions. Okay, axial plane is essentially vertical. Both the limbs are equal in length. Okay, and the deep is deep equally in the opposite directions. Then such type of the fold is called as a symmetrical fold. Such a symmetrical fold is also called as a normal fold or also called as an upright fold. Okay, symmetrical fold are also called as an upright fold or normal fold. Here the axial plane is essentially vertical. Two limbs are of equal length and deep equally in the opposite direction. Okay, so our next type is an asymmetrical fold. Okay, in the asymmetrical fold, in the figure itself indicating that the two limbs are not of equal length. Okay, means the limbs are unequal in length and the deep unequally on the either side from the hinge line. Okay, so axial plane, it may be a vertical or horizontal over here. Okay, and it is the limbs are of unequal length. Okay, and deep unequally in the opposite direction, unequally on the either side of the hinge line. Then such a type of the fold is called as an asymmetric fold. In the figure you can see these are the limbs. Okay, so the length of the limbs are unequal on both the sides. Okay, and they are tilted with the different angles. Okay, or you can say that they are dipped unequally on the either side of the hinge line. Then such a type of the fold is called as an asymmetrical fold. Okay, the axial plane in this asymmetrical fold is essentially inclined. Okay, in the symmetrical fold we have seen that the axial plane is vertical, but in the asymmetrical fold the this axial plane is inclined. Okay, this is the second type of the fold. Third type of the fold is overturned fold. Okay, the overturned fold. In the figure you can see that the folds with the inclined axial planes in which both the limbs are dipping essentially in the same general direction. The amount of the dip of these two limbs may or may not be the same. Okay, then overfolding indicates very several degree of the folding. Okay, the folds means the folds are with the overfolding indicates the very several degree of the folding. One of the two limbs comes to occupy the present position. after having suffered a rotation through the more than 90 degree. The other limb is called as a normal limb. This is an overturned force, okay, where the axial planes uh, are both the limbs of this are dipping essentially in the same direction. Okay, then such a type of the fold is called as an overturned fold. Next type of the fold is an isoclinal fold. Okay, in the figure you can see the groups of the fold and groups of the folds are there in the figure. Okay, and these are means isoclinal fold are the groups of the fold in which all the axial planes are essentially parallel. Okay, the axial planes of each of these folds are parallel, means the component limbs are dipping in equal amount. Okay, here the two limbs of each of these folds are dipping in equal amount. So here there may be a series of anticlines or maybe a synclines. Okay, so isoclinal fold indicating the group of this fold, okay, in which all these axial planes are essentially parallel, or axial planes are parallel, means isoclinal folds indicating the group of the fold where the axial planes are parallel to each other, all the limbs are dipping equally, means equally, or we can say in equal amount. Okay, and this isoclinal fold showing the series of anticlines or sometimes synclines. Okay, so this is our this is the fourth type of this fold, isoclinal fold. Next is an recumbent fold. This recumbent fold may be described as an extreme type of the overturned fold. Here, the axial plane occurs in almost horizontal attitude. Okay, here in the figure you can see that the axial plane is almost horizontal. So here, one limb comes to lie exactly under the other limb. Both limbs, here in the figure you can see that, okay, the axial plane is horizontal. Here the one limb is exactly on the other limb. One limb comes to lie exactly under the other limb, so that the drill hole dug at the surface in the upper limb passes through the lower limb. Okay, in the figure you can see the horizontal plane is exactly vertical, and both the limbs are lie, means one limb is lie on the other limb. If we drill the hole into such a type of the fold, then what happens, it comes from one limb to the another limb. Okay, the lower limb, here the lower limb is called as an inverted limb and the upper limb is called as a normal limb. Okay, so the parts of this recumbent folds are core, then shell, then rock zone, arch. So what does it mean, we will see in detail. In the figure, this is the arch. Arch means what? It is the zone of curvature corresponding to the crest and the throw in the upright fold. Okay, the zone of the curvature which is corresponding to the crease and the trough in the upright fold which is called as an arch. Okay, here such a this portion is called as an arch. Second is in shell. Here this is an shell portion, means it is the outer zone made up of mostly sedimentary rock. Shell is an outer zone of this fold and which is made up of the mostly sedimentary rock. Next is an core. Here this portion is indicating the core. It is the innermost part of the fold and it is made up of mostly crystalline, igneous and metamorphic rock. Shale is made up of sedimentary rock, whereas core is an innermost part of the fold which is made up of mostly crystalline, igneous and metamorphic rock. Okay, then third part is a root zone. Okay, root or the root zone. Here is the root zone which is the basal part of this fold. Basal part of this fold is called as a root zone. This may or may not be easily traceable. Root zone may or may not be easily traceable. Okay, so this is all about the different parts of this recumbent belt. Our next type of the fold is a conjugate fold. In a certain cases, a pair of the fold that are apparently related to each other may have mutually inclined axial planes. Here in the figure you can see that these are the axial planes are mutually inclined. Such a type of the fold are called as an conjugate fold. This individual fold may be inclined, synclined, anticlined or synclined. Okay, so this is the figure which is showing the conjugate folding. Okay, here this is a box fold, then here the syncline fold is there, then third is an anticline fold. All these fold combinedly called as an conjugate folding. Okay, so this is as an in the figure you can see the three axial planes are there which is showing the three different folds: anticline, syncline and also here the box type of the fold. Okay, so combinedly they are called as an conjugate folding. And last type of the fold is an box fold. Box fold. Box fold means what? In the figure you can see the space. It is a spatial type of the fold with the especially flattened top. The top of this fold is flattened and steeply inclined limbs. Limbs are steeply inclined. Okay. Now here almost forming the three sides of the rectangle. Such a type of the fold showing the three sides of the rectangle. Here in the conjugate fold, this is the here the first part of this conjugate fold showing the box fold. Okay, so here the limbs are inclined. Okay, they are showing the and showing it is the flattened on the upper side. Okay, and show this plane showing means this strata showing the box like structure. Okay, three sides of the rectangle you can see in such a type of this block box fold. Okay, then in the figure you can see this is the actual figure of this box fold where the top is flat. Okay, and the sides or the limbs are inclined. Okay, and they are showing the three parts of this rectangle. Okay, so up to here we have seen the different parts, different types of the fold, means the classification of the fold depending upon the position of the axial plane. Okay, so our next point is the recognition of the fold. Means now we will see how to recognize the fold. Means if the fold is absent or present in the in the earth crust. Okay, how to identify this? So the identification means the recognition of this fold in the field is always easy. Is not always easy. Identification of the fold is not easy. All the limbs of the fold are seldom visible, therefore symmetrical study is required for the identifying the fold. कभी कभी ये इसके फोल्ड्स के लिम्स जो है वो दिखाई देते हैं, बहुत बार नहीं दिखाई देते, इसीलिए द systematic study of this fold is very much important. The features which helps in recognizing the folded strata are means how to identify the this folded strata. Uh, the different features have been recognized. So what are these features? First is, in some areas the folds are easily inferred by the topography. Then that time the aerial photographs are used for the purpose. With the help of the photographs the fold can be identified. Okay. Then the repetition of the outcrops of the rock suggests the presence of the fold. In the figure you can see that the repetition of the outcrop is here. Okay, and this indicates that the presence of the fold. In such a cases, care should be taken to eliminate the possibility of the fault. Okay, if the fold is of open type, in the figure you can see this is an fold and it is open here. Okay, so if the fold is open type, the reversal of the deep direction is enough to identify the folds. In anticlines, the oldest rock bed occupy an axial position, and in synclines the youngest bed will occur there. Okay, in the case of the overturn or the isoclinar fold, where all the limbs dip in the same direction, in the figure you can see that here is an isoclinar fold. Okay, so in the case of this isoclinar fold, all the limbs dip in the same direction. Okay, detailed observations are necessary to identify these synclines or the anticlines. Detailed observations are necessary to recognize the anticlines or synclines type of the fold. Okay, then some features which aid in finding out the top and bottom of the bedrock and synclines and anticlines are drag fold, then rock cleavage, cross bedding, oscillation, ripple marks, graded bedding, mud cracks. Okay, with the help of all these features we can recognize the fold. Okay, we can identify the fold. So drag fold means what? This fold shows the characteristics which are similar to the major fold. The axial plane of this drag fold is roughly parallel to that of the major fold, of which it is the part. Second is a rock cleavage. The flow in the figure is there. In the figure you can see the cleavage. The flow cleavage or the silty cleavage is formed due to the parallel orientation of platy and flaky minerals. This cleavage develops parallel to the fold axis, and therefore it can be used in the study of major fold. So with the help of these points or the features, uh, we can identify or recognize the fold. In the graded bedding, or you can say that the sedimentary bed, the coastal grains are always at the bottom. In the graded bedding, the means coarser grains are always at the bottom. Okay, so here we can with this trick we can identify the fold. Okay, our next point is the engineering considerations. Engineering consideration. The fold developed in the areas of the work are important for the civil engineer, in that this makes his work more complicated. Means if fold is present inside the earth crust, and over which we have to construct any building or any type of the structure, then it becomes more complicated work. Okay, uh, why? If the structures are not thoroughly investigated and properly interpreted, any civil engineering project standing on or driven through these folded rocks may be proved not only uneconomical but also unsafe. Okay, means the if we construct any type of the structure on this fold, then it is uneconomical also, and also it is unsafe. Okay, due the all so always to be given the presence of the fold in deciding about the designing construction of such a structure as driving of the traffic and hydropower tunnels, selection of the dams, reservoirs, and fixing the alignment of the roads, bridges, highways. The study of this rock is done in detail. Okay, the influence of the folding on the design, stability, and economy of the structure have been discussed in some details in the relevant okay, study in detail. The proper planning of the work in the folded area is therefore of utmost importance to avoid these possible hazards in the construction work. If we have to reduce the construction cost, and also we have to construct and save building construction, then the proper planning of the work in this folded area is of most importance to avoid this possible hazard in the construction work. Okay, so up to here we have seen what is meant by the fold, then folding means what, then we have seen the classification of the fold based on the position of the axial plane, then we have seen the recognition of the fold, and lastly we have seen the engineering considerations of the fold. Okay, so now we will stop over here. Thank you.